Welcome to the Digital Amateur Television Experimenters Night. This is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. You realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world. Also participate in the night by coming up to the Queen's Domain club rooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30 p.m. local time. We'll see you soon. This is VK7 OTC.
Okay, this is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania with our DATV Experimenters Night. Justin, VK7 Tango Whiskey at the desk, and we've got, have we got a show for you today? We are less than a couple of days away from the Tassie Ham-E-Con conference. Things are a little manic, as you could well imagine, but things are happening, and everything's ready to welcome people to the conference. So it's all coming together. Months of planning will all start to happen Friday night at the barbecue up here, and then also at the actual conference. So looking forward to welcoming everybody. We've got on the stream. Darren, hello Darren, VK4GEO, VK3IK, hello, Nick, VK3BA, Craig, now I don't, sorry Craig, I've forgotten your call sign, GIN, VK7GIN, lovely call sign, I remembered that, Ken, ZL4KEN, I think, and Margaret, and I've forgotten Margaret's call sign, thank you, sorry Margaret. Drop it in the chat. We've got Brad VK3BKQ and Ron Mann VK7RM on the chat, and please drop your questions or your comments into the chat as we go through. So it is as I mentioned, it's a little bit manic right at the moment. We've got oh, hang on, that's not going to work, is it? Oh, there we go. It did work. See, I shouldn't doubt myself. Okay, we have lanyards ready for everybody, absolutely everybody. And if you one of the key things for your lanyard is on the back, for those people who are coming along, there is a QR code. And the QR code is for feedback throughout the weekend, so you can scan the QR code and give us feedback absolutely any time during the weekend, and we actually encourage it. We want as much feedback as we can, and we feed that into obviously the planning as we go through, but also as we develop the next one in 2026. That feedback goes into that planning. So we also have a let me come back here. Sorry about that transition. On the Sunday morning, late morning. On the Sunday late morning, there is a forum making and energising ham radio, and what we will be using that QR code for during the session is to ask some questions. There'll be some questions that we'll put out there that will be available on the Sunday morning. So you can contemplate those, and you can put your answers into those, and we will actually use them as part of the forum. And so there will be sort of semi-interactive, I suppose you'd say. There'll be word clouds appearing up on the screen behind the forum guests, and we'll start to try and develop some of those themes, and hopefully all things going right, and the right amount of presentation goats that have been sacrificed at the right time will enable us to actually present that up on the big screen while the forum's going on. So now ZL4KD, thank you Ken, and ZL3YF, thank you Margaret. And good luck with the conference. Wish I could. Okay. Oh well. Good luck with the recovery from a surgery, Darren. Well and truly. So everything's in place. We made a big hoo-ha about all the raffle prizes last time, so that's all. And what you will find in the back of your lanyard is your complimentary raffle ticket. Everybody gets one raffle ticket, and you're well and truly able to buy many more. There is we're just shy of, I think, $10,000 worth of raffle prizes, which is good because we have a $10,000 limit before we need a license. Excellent. So it is all happening, and it gets underway Friday night up here with a big barbecue. Now, there is, for the conference attendees, they have been invited to the Grote Reber Museum, which is, for those who don't know, the big 29-metre radio telescope that's out at Mount Pleasant that the University of Tasmania looks after. Just next to that particular telescope there is a museum, and it's a museum to Grote Reber, who is one of the grandfathers, I suppose you'd say, of radio astronomy. And one of the people who's credited actually with using a parabolic dish for radio astronomy in the first instance. So that's pretty special. And he lived and had a square kilometre array already. So he got in there first before Western Australia, but a huge array of dipoles, of phased dipoles that he pointed at the Milky Way and actually mapped the Milky Way with RF back in the 50s. And so Grote lived up at Bothwell in the Central Highlands, and interesting guy. The museum has some wonderful artefacts from Grote. He made an electric vehicle, three-wheeled electric vehicle that he used to drive around the place, way before electric vehicles were the in thing. He made one of his other claims to fame was he made a incredibly energy efficient house through a whole range of passive heating and all sorts of things that he actually got an award for. So anyway, the Grote Reber Museum, there is a bunch of about 20 people have said they're coming along. So that's on the Friday afternoon before the barbecue, and then we'll come back here and have the barbecue and a bit of a social gathering, and then into the conference. So it's just off the show. There you go. Your last view before the conference. The Tassie Ham-E-Con over this weekend. So now the next thing I've got for you. Now this is going to be. Let me see whether I can do something here. There we go. This is good. Now. One of the things that now everyone's used to seeing that. Let me head down to. Oh, there's our club rooms. Yeah, that's good. Let me do. This. Okay. Ah, that's better. Okay. Now, I've got... And I have to thank Larry, VK7WLH, for putting me down this rabbit hole. One of the things that Larry... let me just go to here. One of the things that Larry put me onto was the QRP Labs. Now they're a UK group. The QRP Labs, what they call their QDX transceiver, digital transceiver. So they specifically make it and call it a digital transceiver, and I'll go into why they call it that in a short while. This is effectively a little transceiver, so it is a transmitter and receiver. It's an SDR. It is an SDR. They have pared back everything to its absolute minimum, and they even get to the point where they generate the RF inside via software. And I'll show you some interesting charts around that. It is 5 watts, so it's 5 QRP. It's 5 watts native, and it does that through a Class D amplifier, so a pulse amplifier, and it is. Hang on. Let me just go to the right page here. I ripped the front page off. That's a bit naughty, isn't it, Justin? So they call this a digital transceiver. Now, what I can do here it just looks like a black box, doesn't it? What I can do here is actually, if we go across here. And we head in here. Okay. So inside that little black box is a very nicely made PCB. On the back side is processor. So this is the processor, the Atmel processor, the ARM processor. Over here, there is your a little bit of logic glue. There is your power supply down this end. And then on the top side, this IC here is your sound card IC. What it does from the receiver point of view is it is purely a sound card that takes the I and Q signals that come out of the quadrature mixer, and takes those I and Q signals and feeds them in through a high end, so we're talking I think it's 44.1 kilo samples. So this is 44.1. So this is CD level sampling, CD quality sampling at 44.1 kilohertz, and so there is a reasonably high performance sound card on there. There is you can see here there are 4 MOSFETs. There are 4 FETs that sit here. This is the quadrature, not the quadrature, the Class D amplifier, and I'll show you a circuit of that shortly. There's some balance input into that amplifier. There is the low pass filters, which is all of the filters that you're seeing here, and there are some matching transformers here as well. Now, when you get it, if you order this as a kit, and that's the cheapest option, the $69 US kit basically has all of these parts, all of the surface mount parts and all of the surface mount components already mounted on the PCB, on both sides of the PCB, and the parts that you get to actually wind and put onto the PCB are all of the through-hole components. So all of these capacitors, there's some inductors in there, and all of these inductors you have to wind. There is the LED, these transformers, and the connectors that are across here, and those, basically you put those onto the board, and that is all that you do in relation to the kit. All the ICs, all of the other surface mount components have all been already mounted and soldered in place, and the processor has been programmed. So there is a firmware already on that processor when you get the kit. So once you put all of those components onto the board, and can I just say the instructions that come with the kit that are freely available on the website, and I'll post all of the links to this website. If we head over here, here's the documentation that you get with the kit. Fantastic set of documentation. It is a step-by-step guide through the elements. Each of the inductors that you actually have to wind, they take you through how much wire you need, etc., etc. You can see here the instructions start with the capacitors, the through hole. Here we go. This is what you get in the kit. So it's all the through hole components. It is the inductor wire. It is all of the inductor toroids, all the different types of toroids that they use. It's the MOSFETs for the power amplifier, and it's the connectors. And there are some 4 diodes there and 4 inductors, and the LED, and that is basically the $69 US kit. That's the inventory that you actually get with the kit. So you go through, you put the capacitors in. It tells you all of those, where all of those components go. Now, the version that I have is the 5-band. It's the 80, 60, 40, 30, and 20 meter version. There is also, you can order a 20, 17, 15, 12, 11, and 10 meter version of it. And so they are slightly different. They've obviously got slightly different low-pass filters and a few other things on them. So the components for those are slightly different. So it takes you through both elements. You then put in the 6 diodes. You then put in the inductors. So the four inductors. You then go through and put in the 4 MOSFETs for the power amplifier and mount them. Now I've actually mounted them. I did put some heatsink compound underneath those just to make it perfectly so it bonded to the and transferred that heat into the ground plane on the actual PCB. That's what they rely on. And the screw holds the flats of those MOSFETs onto the copper of the PCB to take that heat away into the PCB. You then go through and each of the transformers, it takes you through step by step on what you've got to do. Here's probably the second most complex transformer, which is a little binocular ferrite. And it takes you through the winding of that particular ferrite, and then it takes you through, in each case of the inductors, it actually takes you through and you test, once you've soldered that in place, just to make sure that you've got the solder's actually gone through the enamel on the copper wire. So there are the test points, and then the mounting, so you can see there, and then it goes through progressively. Now this is the most complex inductor. This is L12, and so this is effectively an auto transformer, but it's got a few little complications that you've got to put into the mix. But follow it step by step. Start, end, 36 winds. You basically go through, put on each of the turns. It then goes through how you test that particular inductor once it's been mounted in the board. The higher frequency version slightly different, and so it takes you through. It keeps going. Each of the inductors, each of these low pass inductors, low pass and high pass inductors. So there is a low pass and a high pass filter. So it protects the receive side and cuts down the amount of signal that it's actually receiving, and the combination of the high pass and the low pass give you a band pass filter for each of the bands that you're actually operating in, which is really a must these days for an SDR input. You do not want to overload an SDR input. Some funny things happen when that happens. Then the trifilia wound toroid, which is on the board. In fact, if I go back to when I say trifilia wound, it's this one here. So this one here it's actually 3 bits of wire that are wound together, and they then separate out on one side and the other side into the particular holes. It sounds very complex. It's not. If you follow the instructions, and this is the instructions to actually wind the trifilia winding, and then put it onto the toroid, and then separate out the ends, and then test the ends. You test the ends with the multimeter. You can see here ABC, ABC, and then put them into the holes in the PCB. You can see ABC, ABC, and then you test it. This is how you test it. Put in the LED, put on the connectors. I think the connectors are next. Yes, all the connectors, they're pretty easy, although you do need a fairly hefty soldering iron to solder the mounting points on those. And then put it into, it slides into the case, a very nice little case. So this is what it looks like inside the case with the top off. And you end up with basically what's on your screen in the little screen at the bottom. Now, this one, can I just say, is actually a working model, and you can see here we've got WSJT up. Now, key thing here is this is a digital. Now, this is why they call it a digital transmitter and transceiver. It is only for FSK type digital modes, so frequency shift keying digital modes. So WSJT is a frequency shift mode. All the WSJT, JS8, Call, FL Digi, RTTY, Olivia, etc., etc., etc. If it is a frequency shift keying mode, then what you can use is this particular transceiver. If you want to do CW, or you want to do single sideband or AM with this transmitter, this is not the transmitter for you. This is purely a digital modes transmitter. So if you want to do WSJT until the cows come home, this is the transmitter for you. It's 5 watts as our output on most bands. And that's one of the things. That's one of the reasons you check the inductor once you've soldered it in, because if you've got low power on some bands, you probably have an inductor issue. Let's try to get the ZL2. I just clicked on the ZL2. There's a ZL2 just put out a CQ. This is 20 meters, so 14074. We'll see if we can raise them with 5 watts. I'll be very surprised. This is going off into this is barefoot into an end-fed half-wave antenna that we've got at the club rooms, and so let's see if we can raise them. They do. Oh no, that's -4. So yes, okay. They if they've got a half decent receiver and a reasonable noise floor, we might be able to raise them. I just thought the ideal thing here is to try and do a on screen demonstration of this. Now, the other thing I'll point out after this, if we can or we can't make this contact, we may not be able to. We're only 5 watts into a half wave, and I'm actually not sure in what direction the half wave is pointing. But anyway, we'll see. But you can certainly see from a receiving point of view, it's receiving within the passband of the WSJT FS8 FT8. It is certainly receiving. Around the world, EA8, PY2, lots of Japanese stations. In fact, the Japanese stations. There's a BG5. I think that's China. I think. But correct me if I'm wrong. Okay, looks as if we're probably not going to be able to raise them. Let's see if we can raise the BG5. This will be a bit of a struggle. This is -20. If they're a really strong signal, then we've got half a chance of being able to raise them. But we might be going a little bit here. We'll see whether we. You never know your luck in a in a small city. Hi. And the advantage with FT8 is it's quite quick. It's the 15 second turnaround time, which is not bad. Well, there's a JI1. Okay, let's try the JI1. DU9. They're a -8. That's not bad. We may or may not be able to do this. We are talking 5 watts into a in-fed half wave, and I'd be surprised. I have made a couple of contacts here earlier. Certainly YB9, yeah, -20. Yeah, you're going to be struggling there. And okay, VK3 LGOs, LGQs come in there. But anyway, so let me just come back to here. So a little bit of we'll just watch that for a little while. We've got so the key thing here, and I emphasised it just a moment ago. This is if you have a single tone FSK mode like WSJT, etc. This will certainly work for you. Now he's just come back, so let's try him and -7. We've got half a chance here. Okay, let's see. So now, not suitable for on-off keyed modes like CW. It does not have click reducing RF envelope shaping. Furthermore, it's not suitable for phase shift key modes like PSK31 or modes involving multiple concurrent tones such as WinLink. So only your frequency shift, your single tone frequency shift keying modes. Available in the two 5-band versions, either the 5-band which I've got or the 6-band, which is the higher up that goes up to 10 meters. 5 watts with a 9-volt power supply. I've got I think I've got a between a 5 and a 12-volt power supply. It takes an amp on transmit, and it's hundreds of milliamps on receive, so it doesn't really take that much. Could be used portable through a battery, so that's a definite possibility. Yeah, single signal transmission, 0 unwanted sidebands. It is really clean. I had a look at the spectrum on this, and it is phenomenal. It is actually being generated digitally, the actual RF signal, and so there are very few artifacts which are generated as part of the circuit, because there's no circuit in there needed to actually filter out all of those unwanted signals. So 0 intermodulation distortion, so pretty impressive. It's all controlled through USB. I've got a USB plugged into the device. It a built-in 24-bit 48 kilosamples per second USB sound card, so it's actually higher than CD. It's a built-in USB device. So if we go to preferences, you'll notice, and in fact the latest version of you'll notice here the latest version of WSJT actually has a QRP Labs QDX selection. So this is the latest version of WSJT for the Mac. This is running on a Mac rod at the moment. And if you go to audio, the sound card comes up as QDX transceiver for both the input and the output. So it's really easy to set up. Basically, I went in, selected the radio, selected the serial port that it came up with, and you can tell that through. There's some applications on the Mac, or you plug it in, have a look at the serial port devices that are there, and the one that appears when you plug it in. That's obviously the one you need to connect to. The one thing you can do here is once you've connected is test CAT. If it comes up green, it can communicate bidirectionally with the device. You set up these two on the audio for input and output, and obviously your call sign and etc, etc. But that is literally all you have to do, and you can be off and going and transmitting almost instantaneously, as you can see here. So it's all pretty impressive. Now there is a VK4 that is absolutely rock crushing. I reckon we'd be able to work him. You can see on the waterfall here, absolutely red to orange, and coming in at 7 plus 7. So oh no, somebody else has gone back to him. So yeah. LU9 has gone back to him. Let's see what else is here. HX, I'm not clicking on HX because VK4 HX because I actually made a contact with him before, and he'll be wondering what's going on if I try and make another contact with him. So let's go up here. Just VK5 COL. I made a contact there. Then VK4 HX. You can see here where the red and yellow. The yellow are me transmitting. What else has we got here? There is that JI1. Let's try him again. See whether we can't raise him. You never know your luck. It's actually quite a strong signal. Oh no! Somebody, bang! Somebody's gone back to him. For those who don't know, in WSJT, if somebody else goes back to some station that you are actually trying to contact before you, then it drops your enable TX off, and so it just gives you a signal that somebody else is trying to get in there. So let's try this one. Oh, we're halfway through the cycle, but anyway. Okay, let's see. JH2BJL PM84. Now, what else is here? Okay, it has a built-in SI535-1A synthesized VFO, so that's a DDS, very familiar, used in a lot of things, with 25 meg TCXO as standard. It is very nicely designed board. It is up to revision 6. That's the one I actually got in the kit. Very nicely wave flowed and manufactured, so fantastic. You won't have any problem with that. Here we are. Receive current is 100 milliamps, and then the transmit current is between 1 to 1.1 amps for 5 watts output with a 9 volt supply. So yeah, an IQ output mode if you wish to use a PC SDR program for demodulation rather than the built-in SDR. So you can actually, the IQ come out of, there's a 3.5mm jack on the back, stereo jack on the back, so you can actually grab that as well. The QFU firmware update for lifetime free firmware updates, so fantastic, and the extruded aluminium case, all for $69 US plus shipping. So to get that here, it cost me, I think, a little shy of 100 Australian dollars. Really impressed with the shipping. It was shipped out of Turkey, or Turkey, as they call it these days. It took 3 days effectively to get to me after it was shipped. So I watched and it's shipped via TNT or DHL. And it basically took 3 days to get, 1.5 days to get out of Turkey and get to Melbourne, and then 1.5 days to get to me. So I thought that was pretty impressive for an overseas service. So that is that's the QRP Labs QDX digital transmitter. Now, I haven't been watching the Oh, hello Muzz. Hello Peter, VK3MV and VK7ZMS. Wish it was a raffle you could buy in without going to Tassie. Yeah, sorry. Sorry Colin. Our raffle rules are as such. I just got VK7TW on 40 metres FT8 about 30 minutes ago. Well, there you go. That's Colin. VK5COL. If I scroll up here, there you go, Colin. You're in the log. VK7TW, VK5COL. So there you go. Great bit of kit, yes, and welcome Andy, our UK member. Great bit of kit. More chance of us completing the contact if you held your TX frequency. Yeah, well, yeah, it's probably all over the place right at the moment. Not set, no. And IK, I'm now calling you. Oh, VK3IK. Okay. Let me find you in the VK3IK. On 20 metres? VK3IK. You think your receive level is a bit low? Yes, you're right. It's down in the right on the red line zone. You'll see it's not bad now. There's it's about 20 dB, but if it goes down below 10, I think it goes into the red and tells you should be bumping it up a little bit. So so yeah, VK3IK, not seeing you there. Anyway, we'll keep an eye out. Yeah, okay. But that's the QRP Labs QDX. Fantastic little, quite cheap, only digital, but if you're into digital, fantastic. Absolutely love it. And it's well worth a look. And QRP Labs, can I just say, QRP Labs sell a whole bunch of other transceivers and other products, so it's well and truly worth having a look. Now there was just a few things I wanted to point out, and I'll put the links to put a link to. Only got to tick the hold TX frequency box. Yeah, okay. I thought I had that hold TX frequency. Okay. Now let me go back here. There was just a few things I wanted to point out. I said that this was there are so many different, absolutely so many different ways that they do things with this particular transceiver. What the designers have thought about is, how do we design a transceiver that removes as much of the I suppose the elements of a transceiver that create artifacts and maintain it in a digital state all the way through, both on the receive chain and on the transmit chain. So this is the this is the transceiver side of it. So it's a pretty stock standard generation 2 SDR, and if you don't know what I mean, have a look at my talk to the Linux conference in 2017, and I go through each different generation of the of SDRs. So it's a sound card SDR. It relies on the sound card. It's not a direct down conversion or a direct up conversion. It is a direct up conversion, but it's not a direct down conversion. So and so it uses a sound card for the receiving chain. So what I wanted to do here, I just need to find the chain, the 58. Just bear with me here. 58. Here we are. Okay, so on the transmission side, they are directly generating the RF waveform, or at least interpolating it, interpolating it to a full waveform. And this is how they get such a clean signal out, and they don't need all of the filtering elements to get rid of all the nasty bits. So on page 58, it goes through how they this is the simulation, if you like, of how they generate the transmission side of it. And it's well within the capabilities of the sound card, the electronics that's there. But what that then means is the way that they generate it, they don't need a full amplifier to then amplify it. They can then use a Class D amplifier, which is the next picture that I wanted to jump to, which makes the transmitter, and they go through how they generate that waveform. But what it means from a Class D side is they effectively have it makes the transmitter so much simpler, because they're in effect they're using a push-pull type arrangement, but because they're digitally generating it, they are able to drive it directly from the digital output. So here's our 4 FETs, the BS170 FETs, MOSFETs, and you can see this is literally how simple the transmitter is. It goes out to the matching transformer that joins together the two signals. One side is the if you like, the negative side of the signal, and the other side is the positive side of the signal, and then they drive that directly through the 7-4 ACT08 gates in a digital manner. And so I just can't believe how simple that they have actually pared this down. And I would be expecting an incredible amount of noise, digital noise, to be generated on this, and there just isn't. And so they have matched components. They have made sure that the algorithms they're using to generate that signal are pure, and they get pure signals out of it. So yeah, really interesting. And it means you have probably, I don't know, half to a third the number of components that you would normally have in a transmitter. And there are a whole lot of screen grabs here from the spec-ans to show you how clean the signal actually is. They switch the low-pass filters, so that's not unusual. They do that, the low-pass and the high-pass filters. That's the MOSFETs. They use MOSFETs to switch the relevant filter in and out for those, and they use the diodes. That's what the 6 diodes are there for. Now there was another thing. Okay. In the firmware for the transmitter, you can actually go into a little terminal program. And there's a little terminal program comes up. This is you can see here. This is just a PuTTY session that they've got into the firmware, and there's a little monitor program, if you like, or a terminal program that you use to get into the monitor, which enables you to actually configure. You can configure, look at the configuration settings that are in there, and adjust them or not if you need to. You can also put it into there's a wonderful this goes through the seeing how clean the output is. The push to talk comes out, that's fine. The power supply, they go through each part of the circuit. There is, what page? 91. 91? Is that right? Now there is a wonderful audio sweep function that is done through ASCII characters. So here's your bandpass from 0 to 3850 So here's 100 hertz, 1000 hertz, 2000 hertz, 3000, 3850, and this is the audio spectrum, which is, can I just say, pretty damn linear. It's almost flat from just over 100 hertz through until what? Just past 3200 hertz. So it is literally flat for most of the passband, which is unheard of in most transceivers. It's all over the place. You get it tapers off at the really low frequencies, and it tapers off at the really high frequencies. So there's a little audio sweep tool that comes as part of the terminal program, the monitor program that is built into the firmware. So you can run this without having to have any sort of test equipment. You can run it and it will show you what it's hearing from an audio perspective. And if you don't get something that looks like this, then there is obviously something a bit haywire about something, and you can do some troubleshooting on the circuit. So I couldn't believe it. I'll show you one of the things. Come on. Let me go to. We actually need to go out of here. Let's head back to here and here. There we go. So if we head here, I had this on 20 meters whisper overnight, over the last couple of nights. That's really out of focus, isn't it? Let me see whether I can get that any better. I can't get that any better. Oh, that's a bit painful, isn't it? No, that's making it worse. That's made it worse. Okay. Sorry, that's about as good as it gets. But actually, I know what I can do here. Let me bring up WhisperNet on the PC. Come on, use the tools in front of you, Justin. And if we transition over to this, all right. This is where the Whisper database. If we head down here and go, I had it on 20 meters. I'll leave it and me, and I will need to update for the last 24 hours. And if we do an update, so there is that's okay. North America, pretty much North America. Here we've got Hawaii, we've got into Alaska, we've got ZL down here hidden by all of the lines to America. We've got Australian states, we've got a bit of Japan, we've got China, we've got Malaysia, we've got, I'm not sure, we've got Denmark, we've got Sweden, we've got Norway, we've got Europe, that's all Europe, Spain, we've got a little island off this side of Africa. But that's probably, well, that's the last 24 hours on 20 meters whisper, using the device. So yeah, I just one of the things, Whisper is can I just say, Whisper is an absolutely fantastic test program for testing not only transceivers like we've got, but also testing. It helps if you do a transition here, Justin. Absolutely fantastic for testing transceivers, but also testing antennas. If you wonder how good an antenna is, leave it on Whisper overnight, both transmitting and receiving on low power. It can only be, you only need to put out 5 watts and see what hears you and what you're hearing. and if you're confident that your transceiver is good, you will get a pretty good idea over a day how good either the transceiver is or the antenna is. So, and also where that antenna is pointing, or where it's favouring, which part of the world, etc., etc., etc. So, now, oh, hang on, I've got more comments. Okay, I've done that. 100%. Thank you, Colin. Looks like it would be a great little rig for FT8 from the car. Well, funny you say that, Colin. Because one of the conversations I had with Larry, VK7 WLH, who put me onto this in the first place, was having a Raspberry Pi with a 7-inch touchscreen running Whisper, running WSJT, and you put this in the box, basically as the transceiver, and you have a little FT8 Go Pack for soda or whatever, or mobile in your car or whatever. So I just it's absolutely phenomenal what's possible. Now let's have a look here. He's, yeah, I won't contact VK4AWB because he's clearly looking at Europe. We're getting him off the back of his beam, I reckon. That's HX we've done. Let's do AWB. We'll piss him off. I'm sorry. Or we might get, you never know, we might be getting him long path all the way around the world and round to us. So you never know. But yes, he's trying for Europe. And as you can see from the whisper signal, it's Europe is well and truly open. He's strength 6. He's strength 6. So absolutely fantastic. No, we'll hold that off. I don't want to. He's probably cursing me right at the moment. Who else is here? YC8. Let's see. YC8 PAD -12. Yeah. We'll see. We'll give it a go. You never know. We'll give it a go. Okay, here we go. We are transmitting now. Let's see. You've got to realise it's 5 watts, and they're probably running a minimum of 100 watts, I'd say, or something between 50 and 100 watts. And if their noise level is anything like the standard suburban noise level, then you'll be going to get anything other than the really, really strong signals, and maybe if they're out in the country and have a low noise level, then they might pick you up. So 5 watts, you would be struggling for a suburban station to even see you on the waterfall. There is a lot of noise around. Yeah, I don't think he's hearing us, and I'm not sure where this NFED is. If Murray is on, Murray might be able to tell us. Now back to 40 meters. Let's hold that. Head off to 40. I was on 40 originally, and we'll see how we go. Our luck in the big city. Oh yeah, lots of strong signals, so that's excellent. Let's see, and it's probably a NFED halfwave on 40, I would suggest. -15, maybe. Really struggling. That would be pushing the envelope here. Some -3s and some 2s in there. The JHs. Let's see. I may or may not have sacrificed the right number of and yeah, VK3IK, well and truly. I didn't test whether this antenna is okay. Murray may be able to tell us. I basically took it off the back of the transceiver that we used for our club. I would say not in this particular case. So anyway, enough for the demonstration. It's certainly hearing, and it's certainly hearing plenty of signals. Minus 17, no. Minus 18, no. Just might have a problem on the transmission side. But anyway, that's how we're going for time. Oh, okay. I'll call it quits at that. Now, space weather, nothing to report at this stage. So it's been a bit quiet. The sun's been a bit quiet over the last week or so. What's ahead? Okay, why have I got 3 people watching me? All very intently. That always bothers me because it's something going on. So obviously the Tassie Ham-E-Con, well and truly, Ham-E-Con. I'll stop saying it next time. So we've got -8. Ooh. Okay, minus. We've got VK6. Okay, let's try VK6 and see. You never know your luck. So now, the November the 6th, which is normally a presentation night, is we're putting on a pizza night for our volunteers at the conference. So there won't be a stream on November the 6th, people. So just warning you, there won't be one. Unless you want to watch us all, eat pizza, which you probably don't. Oh, now Murray, club NFED half wave goes from the back door to the tower and then north to the boundary fence. Okay, well, okay, that's probably okay. Probably okay, but anyway, it's certainly hearing okay. Which anyway, I need to put a SWR meter on it. So VK3IK definitely. November the 13th. Now, you might be interested in November the 13th because we are streaming that night. It's a bit of a conference debrief, and we'll have the feedback that we got from the conference. Oh, red line. Cool. Excellent. Oh no, VK3IK. Oh, no. VK3IK. Okay, there you go. That's better. Look at this. We've got them on the chat channel, and we're making contact with them. You're coming in with a report of +26. So you're blowing us out of the water, yeah. And if you look up at the waterfall, they're one of the very, very strong signals. Yeah, I can certainly see you, but you're obviously not hearing me. So with my little 5 watts. Oh no, there we go. -7. I love it. Oh, thank you very much. Well, there you go. We actually proved that we made a contact. So I love it. I absolutely love it. Okay, so November the 13th, the conference debrief and the feedback forum, so we'll have a bit of an idea. December the 1st, we won't have a stream. December the 1st is actually a Sunday. We have an end of year celebration up here, a bit of a barbecue and a bit of a working bee up here to get things in order in our shack. So that's got there in the end, yes. Spot on. 73, I love it. What else are we? I want to make a Japanese contact. That's what I want to do. -7. Let's see. I doubt it, but so you were getting me -7. So yeah, okay. That's not That's not shabby for 5 watts, and I think it's 5 watts. Let's see whether we... no. No, they've gone back to... Now, why didn't that... JA5GYU, yeah. Why didn't that stop? Not sure why it didn't do that. Let's see. You never know. Sorry, I'm... That's overpowering audio buzz on the stream while transmitting on this band. Well, there you go. See, it must be doing something. Thank you, Muzz. Thank you for letting me know that. Fantastic. So let me just disable that and hold that. Pretty good for 5 watts. I'm doing legal limit. Well, there you go. And you're coming in plus 26 into Hobart. So good stuff. All right. Now RF resistant. Looking forward to the conference. Fantastic. We'll catch up at the conference, and we'll see everybody who's coming down. It all kicks off in a couple of days' time with the big barbecue. The Great Reba Museum first off in the afternoon, Friday afternoon, and then the barbecue, and then into the conference. So you've heard enough from me. One thing, for those people who are in VK7, there is what we're classing the mother of all car boot sales, which is happening in January. So middle of January, we're going to have a huge big car boot sale up here, and we will have some very impressive sorry, I'm very distracted by VI4 Polio. It must be a special events per station. VI4, that's us out of Queensland. Let's see whether we can work VI4 Polio, which is coming in as plus 18. No, they went back in. Come on, come back to us. You don't want to talk to him, you want to talk to us. Anyway, okay. Let's see. AI4. Let's see whether they decoded our transmission, or they got the JA1. They might have the JA1 coming in. Let's see. No. Okay. No. Hold that. All right. Enough of my mucking about. All right. Look forward to seeing everybody at the conference. And this has been VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night. And we'll catch you next time. 73.